Afternoon if you're calling in from the East Coast. If you're calling in or listening in from the West Coast, good morning to you as well. My name is Tom Salas. I'm the Director of Sales at Metrics Contract Services, and today we'll be doing a webinar in our series, which we refer to as Quickinars because we try to keep them short. So today we have a 15-minute presentation followed up by a 15-minute question and answer period. We will, excuse me, I just want to get to my next slide. We will be using one of the features in GoToWebinar to ask any questions that you might have of Anshul Gupta, who is the presenter. Just use the chat feature. So if you look on the right-hand side of your screen, I assume that it's on the right-hand side of everybody's screen. If you just type in a question and hit send, it'll come to me, and I will moderate the questions as we go through the presentation, and I will either ask Anshul to address them as he's going on, or we'll save them to the end. I will monitor that. So today, what I'd like to do is let me turn my screen over to Anshul Gupta, and I will introduce him. Anshul is the Associate Director of Pharmaceutical Development at Metrics Contract Services. Anshul has been with our company for 7 years and supervises a team of formulation scientists, specialists, and technicians who develop solid dosage forms for phase 1 through phase 3 clinical trials. He and his team are also responsible for any scale up and any technology transfers or any validations that might be associated with those materials. His group also oversees clinical trial batch manufacturing under GMP guidelines. He supervises any technology transfers and is responsible for all documentation for clinical trial materials batches. Anshul, you should have the controls, and I'd like to turn this over to you.
Thank you, Tom. As Tom said, good morning, good afternoon, everyone, depending on where you're joining us from. I'm today going to very gladly share a study with you, which we conducted here at our site in Greenville, North Carolina, at Metrics Contract Services. This study focuses on a use of 3 different binders which belong to 3 different categories or classes, if you want to call them, and how those binders affect the dry granulation or roller compaction, and then also tablet compression properties in a model formulation. So, as I said, the purpose is to look at binders, different binders, and also look at how they impact the roller compaction and tableting properties. We're going to go right into the methodology used for this study. So this is a very typical and a very normal formulation, a dry granulation formulation, I would call it. You have your API, which is about 30%, so this is not a low drug load, which would be, I would say, 5% or less than 10%. And this is not a high drug load, which is to say that it's not more than 50%. This is kind of somewhere in the middle, which is typically what we see as a CDMO from our clients. We selected this 30% because of that reason. Then we have 3 other components in this formulation other than our API. First one is a disintegrant. In this case, we use crosspovidone. We have a lubricant, which is, in this case, is magnesium stearate. And the main focus of our study, of this study, as I said, was the binder. So we have 3 different categories of binder, which was used for this study. You have Avicel DG, which, if you don't know about, is a co-processed, spray-dried, co-processed material, which is composed of Avicel and anhydrous dibasic calcium phosphate. You have the second category, which is a physical mixture of Avicel and dibasic calcium phosphate. So basically the same 2 components which are present in Avicel DG, which are co-processed, spray-dried, and are sold, and that material is sold by FMC. We actually here made a physical blend of the same 2 components, and we call that as the second part, one of our binders in the study. And the third binder is the Qualidone VA64 fine. Qualidone is basically, if you look under copovidone in any of the excipient handbook or other information, you'll find that material there. It's a copolymer of two different polymers, and this is being sold by BASF. Now, just wanted to point out why we selected these categories, because Avicel DG is composed of a plastic material and a brittle fracture material, so Avicel and dicalcium phosphate, and Collidone is made up of more of a plastic material. So there are differences in the physical properties of the binder itself. The second reason was Avicel and Collidone are very different in the amount that we use in a formulation. Avicel is used at a large quantity, and something like a Collidone is used at a very small amount. Going into our processing parameters for this study, just wanted to point out that we used Gupta's roller compactor, which is one of the newer roller compactors. And the good thing about Gupta is it's fully instrumented, it's fully automated. It can help you to do studies like that, where you can fix certain parameters and then change certain parameters, so you can see the effect of the parameters you're changing. So in this case, the parameters we were varying were ribbon thickness, which is your roll gap. Then we had roll force and roll speed. So we have three different parameters that we were changing over this study. And I'll talk a little bit more about that in the next couple of slides. The parameters that we did not change in roller compaction were mill speed. So this is a oscillating mill, which is part of the Gupta's roller compactor. We did not change the speed of the mill. And we also did not change the screen, which goes inside the mill. So those were our constant, I guess those are not variables, those are our constants for this study. We also did not change the compression force used to compress these tablets. These tablets were compressed at about 20 kilonewton compression force. The next slide, which is in front of you right now, is the formulation which was used. So again, you can see, kind of described that in the last slide. You have your API, you have your magnesium stearate intragranular. That's typically used to avoid any sticking of the API to the rollers. You have your crosspovidone, which is a disintegrant, and then you have either of the three binders. You have either the Avicel DG or the combination of Avicel and dicalcium phosphate in the second row, and in the last row on your right, you have Collidone V64 fine. So you choose between 1, 2, or 3, and you do your studies. You pass this intragranular material through the roller compactor, and then what comes out of the roller compactor after milling, you calculate the yield, and then you add your extragranular components to make your final blend. The extragranular components in this case were, again, the lubricant, which will help for the formulation not to stick to the tablet punches, and crosspovidone, which is a disintegrant. So going into the study itself, this slide in front of you, I want to point out that it helps to look at it in columns rather than rows. So if you look at the leftmost column, that's materials. So you have three different materials, which are binders. You have Avicel DG, you have the Avicel dicalcium phosphate combination, physical combination, and then you have the Collidone V64 fine. The process parameters, as I talked about, are listed on the second column, out of which 2 were not changed. So mill speed was constant at 90 RPM. I am showing 120 RPM, but that was not part of this study. It was this study, the part I'm showing you today, the mill speed was held constant at 90 RPM. The granulator screen, which is the oscillating mill screen, was also fixed at 0.8 millimeter, which is equivalent to about 20 mesh. So the three parameters which were changed were roll force, ribbon thickness, and roll speed. This slide describes to you basically describes the process flow. If it helps to visualize what the process was like. So you have your intragranular mixture being blended in a V-shell blender. Then that intragranular blend was added to the Gertais, which you see second figure from your left. And it has a mill, as you can see at the bottom. If I can use my mouse here, this is where the mill is. These are obviously your rollers. And what you get at the bottom is already milled granules. So you put your powder on top and you get your granules at the bottom. You then take your granules and you add your extragranular components and blend it, and then you compress it at the end with a tablet press. In this case, we used the instrumented tablet press. So we were able to look at the compression force, and we were able to hold the compression force constant throughout the study, which is very important to be able to judge the differences between the formulations. That brings us into the results section. So first slide in the results section shows you the differences between the three binders. The y-axis here shows you a ratio of granules to fines. In this case, granules are defined as any material which is held above a 60 mesh screen, which basically equals to about 250 microns. And fines are defined as any material which goes through a 60 mesh screen. So anything which is under 250 microns would be your fines. And then the x-axis shows you the increasing roll force from 6, 12 to 18. Also want to point out that the roll force for a Gertais roller compactor goes anywhere from 1 kilonewtons all the way to 20 kilonewtons. In this case, we hold the roll gap at a constant value, which is about 2 millimeters. And you can clearly see the differences where the bar on the backmost part, which is shown in red, it shows you that there are much more granules when you use the Collidone V64 fine compared to either Avicel DG or the combination of Avicel and dicalcium phosphate. So it's clearly visible there that using that binder gives you some advantage or a lot of advantage on the amount of granules that you manufacture. Very similar slide, but in this one, the one I'm showing in front of you right now, the roll gap is at 3 millimeters, and we see exactly the same pattern. So this result of Collidone being a superior binder in this case, in this study, also is exhibited very clearly here. We worked with one of our colleagues from Campbell University in Raleigh to do some principal component analysis for this work for us. And what they found was is shown in the next four or five slides in front of you. First of the slide shows you that there is a correlation. It's a score plot for principal component analysis. It shows you clearly that there is a correlation, positive correlation between 4 different outputs, which are tablet thickness, granules to fine ratio, tablet breaking force, and Carr index, and that these 4 responses have an inverse relationship to tablet friability. And that makes sense. If you think about it for a second, that does make sense. But what also is clearly shown from our study is what is in front of you right now, is that the Collidone V64, which is shown by KVA64, all the data points we got for that had a very positive relationship with the last slide. So if I go back a slide, you can see all the 4 properties I talked about, which are important for a tablet manufacturer and the tensile strength of the tablet. KVA64 has a positive relationship with those factors, and that will become a little bit more clear in the next slide. So the next slide is a loading plot, again, principal component analysis. This is showing you one of the outputs we got for granules to fine ratio. Again, granules are material over 60 mesh, and fines are under 60 mesh. This one clearly also shows you that KVA64 has a positive correlation with the amount of granules we get. and that the Avicel DG and the physical combination, which is your PADCP, has a negative correlation. What was also interesting was roll force had showed a positive relationship, which is expected because the more compression force you use, the more granules you expect to get. Ribbon thickness had a negative correlation, which is also very easy to understand because the lesser the gap, the more denser the material comes out and the more granular the material is. We also saw a good correlation, a negative correlation, but a strong negative correlation for combination of two factors, which is roll force and roll speed, which is shown in front of you here. Going into the next slide, which is for disintegration time. Again, KVA64 has a positive relationship. So basically what this is showing us is KVA64 is a good or great binder in this case, where it does increase the tablet, it decreases the tablet porosity and it increases the disintegration time. So you do get tablets which are more harder and they have more tensile strength. Not just from the disintegration time, but as a study as a whole, I can say that. And Avicel DG and the combination of Avicel and dicalcium phosphate had a negative correlation, which is seen in front of you, to the disintegration time. Tablet breaking force. Again, KVA64 showed a positive correlation, while Avicel DG and the other physical mixture had a negative correlation. Roll force, this is understandable again, that the higher the roll force, the stronger the tablet, and the more breaking force you are going to need. So that was an inverse relationship. We did see that a combination of roll force and roll speed, which is shown as one of the bars in the slide in front of you, had a positive correlation with tablet breaking force. And we are currently investigating that a little bit further on some further studies. So that some of this data is interesting for some future work. But there is some information here which you fully expect, but it was good to see that information and relate to the right choice of binder. So with that, I'm going to talk about a couple of slides for the conclusion of this work. Of course, as you saw, present investigation showed that if you select the right binders and you have the right design space, you can study the interaction of those binders to its effect on the granules and the tablet properties. In this study, we also saw a very positive correlation and our tableting properties could be shown as KVA64 being a better binder than the physical mixture, and a physical mixture was a better binder than Avicel DG. Again, this relates to only this study. We're not trying to really propose that Avicel DG is not a good binder. It just depends on the situation, depends on a lot of different factors. But Colidone V64 Fine did show a major improvement in binding capacity for this study. Also, it was very clear that KVA64 gave us the most amount of granules. And one thing to point out here is also that KVA64 as a binder was used at the least amount. So only 6% of KVA64 was used in the formulation compared to Avicel DG, which was used at 64%. And also the physical mixture totaled up to 64%. So there is a big difference in the amount of the binder, which is giving you the properties you need. Tablet hardness was found inversely proportional to roller compaction force. So this is something very understandable. The more roller compaction force you use, you have your blend losing some of that compressibility, and then you don't get hard tablets. And this study also clearly shows that you need to study, obviously, the effect of binder, the choice of binder, and you need to create a design space where you can get the best ability, you can get the best tablet with the desired quality attributes with the choice of binder, if you need to use a binder. So with that, I would like to conclude, and I thank you all for your time, and I would be happy to take any questions. At this point, I'm going to turn it over again to Tom Salas.
Well, Anshul, that was a great presentation. I appreciate you taking the time out to put all that data together and share it with the folks that joined us. I just want to remind anybody, I have not seen any questions come in, but I do just get one now. So let's see if you have questions, use that chat feature, they will come. Anshul, the first question that came that has come in is, under what conditions would one need a binder? So I guess if you are looking at the characteristics of the API.
Right. That's a good question, and I kind of ended my presentation with exactly that statement. That, you know, let's make that clear. You don't always need a binder, so you shouldn't just. Binder is necessary, especially when your API does not have any binding capacity or has a very small amount of binding capacity. So a binder should not be the first choice, but also we have to remember that most of the binders are typically used as diluents or fillers in the formulation. For example, Avicel, for example, lactose. All of these fillers are also classified as binders. So they do have dual function in that case. So once you do some initial experiments with your API, that's the stage you will, I would say you would do some initial small-scale experiments and then decide if you do need a binder or not. That's my answer.
If anybody else has any other questions, just please send them on in. Anshul, I just have I'm the layman in the crowd, I guess. But when you are presented with a new project and you're working with an API for the first time, how do you choose the manufacturing process that you want to pursue, going from a dry blend to a dry granulation to maybe a wet granulation or a fluid bed type thing? As a formulator, how do you do that?
Well, it's fairly simple, but also is the most important thing, obviously. So there are a lot of properties which affect that. I'm going to point out some. First of all, you have to think of what is the physical nature of the API itself. What is the bulk density of the API? What would be your strength of your formulation? So either tablet or capsule in case of solid dosage form. What strength are you wanting to manufacture your dosage form? And then in that case, what clinical phase you're in. You don't necessarily need to make a tablet formulation. You could choose a simpler formulation in a phase 1 study. So we do look at those things where we don't try to, for our clients, we don't try to make the most complicated formulation. We make them a phase-appropriate formulation. When it comes down to choosing the process itself, chemical compatibility of the API and how the API reacts to heat and moisture are obviously very important properties. And as I said, physical properties such as bulk density and flow are the other more important properties, where if your bulk density is very low, you surely do need to densify the API in some way, which then you get choices of either using any form of densification, but the common ones would be dry granulation or wet granulation, and so forth. Yep.
Okay, a couple of other questions have just come in. So one is, the study used Avicel pH 101. Would Avicel pH 102 be considered a filler and a binder?
I think so. So the reason, yes. I mean, obviously the answer is yes. But the reason of choosing this Avicel grade was that this was the grade of Avicel we think, or based on our research, we found that was part of Avicel DG. So we did not want to change that We didn't want to go with a different grade of Avicel. We wanted to keep the same grade of Avicel as what was part of DG. That's why we chose this one.
Thanks for clarifying that. And then one other question: does the FDA require any specific, or does the FDA require any specifications when it comes to using binders?
So the binding capacity, I would think couple of different properties. Maybe particle size would be one of the properties where you need to focus on. I don't think FDA requires that, but if you do a DOE or come up with the critical attributes of the excipients you use in your formulation, if you work with a supplier which has a good handle on the particle size distribution for the binder, then I think if you normalize for that, you are in a better shape compared to a uncontrolled particle size. So for example, Avicel DG has average particle size of from 35 to 55 microns, and that's the specification. It's always between that. Collidone, on the other hand, the two grades of collidone, so VA64 fine, which was used in this study, is a finer grade, so it has an average particle size of only about 15 or 17 microns. So it's very small, and that property is very important because that does help the collidone to go into those small spaces and interact with the API in a more better way than a more larger particle size binder would. Yep.
Well, thank you very much again for answering that question for everybody. You know, I think we are. Let's see. There may be one other. Let's see. There's a question. There's a question about dissolution. Let me just see if I can. Did you, in this study, Anshul, did you do any dissolution comparisons or anything like that may have been able to give you some additional data?
We did not. So we did not do any dissolution work here. That was something we talked about, and that's something which is, as I said, is extension of some of the data we got from this study. So we do plan to do that in the future and study some of the effects more in detail. In this case, we only looked at the physical property of the tablets, so we looked at disintegration time. That's the only parameter that we, because we were working with not an insoluble API, so we really didn't think dissolution needed to be done right now. I thought disintegration was a good parameter, or a good, not parameter, but a good end result that we can go with and we can judge the formulation. So in this one, we just ended up choosing disintegration time.
Okay. So it looks like dissolution, as you kind of continue on with the study, you'll be looking at dissolution as to gather more data.
Right. Yeah.
And I think we got time for there's one last question that came in, and that will kind of wrap up the half hour. The question is around setting the parameters for the roller compactor. And I'll read it as is. A few of the roller compactor parameters were varied in the case for this study. For an actual GMP batch, would this be conducted at the beginning of the manufacturing process of a batch, or would this test be done in a separate test run?
That's a good question, and that's what I would call a practical, more of a practical question. And I think about those kind of questions a lot. So it depends on if you know where your starting point is. So I mean, obviously you're not going to go into a GMP batch not knowing anything. I hope, and most of the times you don't. You try to do, or we try to do a non-GMP batch first, very small batch. We're not talking about using a lot of API, and getting close to the parameters, avoiding all the edge of failures, and you get close to where you think you want to make the formulation, or where your process parameters should be, and then depends on the flexibility and the number of units that are needed out of the GMP batch. If yield is not a big concern, now it is always a concern. You don't want to just eat up all the units for a study. You need to supply some or more to the clinical study. So we weigh that together and we try to come up with a plan with the client to, maybe do some of the non-GMP work towards the end of the run if we have enough information about processing parameters at the start. If we don't, then we could have some flexibility in our batch records to basically come up with the right parameters and then set the parameters and then start the batch processing. In that case, you would just take whatever material which was ran through the roller compactor and you account that as waste. Or as you have to account for it in the batch, but you could still use it as for non-GMP purposes and do some work there.
Okay, well, I think out of respect for everybody's time and our promise to make this a Quickinar, it looks like we're just about out of time. I want to thank the folks at Sinclair and Company. They are the folks that help us put together these Quickinars. They're out of the Raleigh area in North Carolina, and we thank them for all their hard work doing this. Tomorrow, everyone that has registered and signed in will get an email from Anshul and I. It will include his presentation as well as his full paper that on this study. If there's any questions that you have once you receive the paper or the presentation, you can send that question directly to me or to Anshul, and we will make sure that you get a response either via email or even if you wanted to pick up the phone and have a little bit further chat with us, we'd be more than happy to do that. So with that, I want to thank everybody for their time, and please keep an eye out for our next Quickinar as we develop the next topic. So thank you, everybody. Have a good day.
Thank you, everyone.